x equals minus b plus or minus the square root of b squared minus 4ac over 2a is the quadratic formula. If you square any real number, the result is greater than or equal to 0. So if the value under the square root sign is negative, x cannot be a real number and hence there are no real solutions. If the value under the square root is equal to 0, then both solutions will be the same. For the quadratic function fx equals ax squared plus bx plus c, the expression b squared minus 4ac is called the discriminant. The value of the discriminant shows how many roots fx has. If b squared minus 4ac is greater than 0, then fx has two distinct real roots. If b squared minus 4ac is equal to 0, then fx has one repeated root. If b squared minus 4ac is less than 0, then fx has no real roots. Now remember, you can use the discriminant to check the shapes of sketch graphs. Let's take a look at these graphs of y equals fx, where fx equals ax squared plus bx plus c. When b squared minus 4ac is greater than 0, there are two distinct real roots. So when b squared minus 4ac is greater than 0 and the coefficient of x squared a is greater than 0, the graph will have this shape. When a is less than 0, the graph will have this shape. B squared minus 4ac equal to 0 means there is one repeated root. So when a is greater than 0, the graph will have the shape shown below, and when a is less than 0, the graph will have this shape. When the discriminant b squared minus 4ac is less than 0, this means there are no real roots. So the graph does not cross the x-axis. So when a is greater than 0 and b squared minus 4ac is less than 0, the graph will have this shape, and when a is less than 0, the graph will have the shape shown below. Fx equals x squared plus 8x plus 3. Find the value of the discriminant. So, b squared minus 4ac is the discriminant and a equals 1, b equals 8, c equals 3. So, it's 8 squared minus 4 times 1 times 3 equals 64 minus 12 equals 52. Find the values of k for which fx equals x squared plus kx plus 9 has equal roots. So, for equal roots, b squared minus 4ac has to be equal to 0. Here, a equals 1, b equals k and c equals 9. Now, substitute each of these values to b squared minus 4ac equals to 0. So, b squared minus 4ac equals 0 means k squared minus 4 times 1 times 9 equals 0. K squared equals 36. Taking the square root of 36 gives us k equals plus or minus 6. So, k has the values plus or minus 6. Find the range of values of k for which x squared plus 4x plus k equals 0 has two distinct real solutions. So for two real solutions, b squared minus 4ac is greater than 0. Here a equals 1, b equals 4 and c equals k, so it's 4 squared minus 4 times 1 times k is greater than 0. 16 minus 4k is greater than 0. 16 greater than 4k gives us k less than 4. So, for any value of k less than 4, this equation will have two distinct real solutions. Since b squared minus 4ac is greater than 0 involves an inequality, the final answer will also be an inequality. Find the range of values of k for which 3x squared minus 4x plus k equals 0 has no real solutions. So, b squared minus 4ac is less than 0. Then substituting the values of a, b and c gives us minus 4 squared minus 4 times 3 times k less than 0. 16 minus 12k is less than 0. 16 less than 12k. Dividing by 12 gives us k greater than 4 over 3. So, for any value of k greater than 4 over 3, this equation will have no real solutions.